Isoquant. A line of equal or constant economic production on a graph, chart, or map.
As combinations of inputs that yield the same level of final output. For the particular versions that we will be using, we will assume that the firms have neoclassical production functions. That is to say that they exhibit constant returns to scale, diminishing marginal returns to an individual factor. The particular examples we'll use will have capital and labor used as inputs into final production. Factors will be mobile between industries without restrictions. And finally, we will be assuming that the firms are perfectly competitive in both final product markets and input markets. The traditional way to depict isoquants is in a graph with the horizontal axis as labor and the vertical axis as capital. So we will be depicting the amount of capital and labor, in this case 2 units of capital and 1 unit of labor, that are used to produce 10 units of the final output Y. Notice as well that we're depicting an isoquant where there is no substitution between capital and labor. This is a special case where capital and labor must be used in this proportion, 2 to 1, 2 units of capital, 1 unit of labor, in order to produce any level of final output. This means, for example, if we increase the units of capital to 5, but retained only 1 unit of labor, we would still only produce 10 units of the output. Similarly, if we kept capital at 2 and increased labor to 8, we would also produce only 10 units. In this instance, the isoquant for this particular type of technology is depicted by the red line. Again, this is the case when there is no substitution between capital and labor. It must be used in this proportion, 2 to 1. So if we wanted to increase output, we would have to increase both capital and labor. For example, to 4 units of capital and 2 units of labor. Because it's a constant returns to scale technology, if you double the inputs, you'll double the output to 20. In this instance, the family of isoquants representing different levels of output will all have this same distinct right-angled shape, regardless of the level of output. This also means that there will be a constant level of capital-labor ratio for this technology. The KL ratio is always the same, regardless of the level of prices for labor and capital. So whenever people talk about a kind of industry which is very inflexible, that always must use inputs in always the same proportion, the exact number of workers, the exact number of machines, 1 for 1, or any inflexible combination like that, this is the kind of isoquant that's associated with that idea, a very inflexible kind of technology. So now we want to bring in the cost side of the equation for the firm, because the firm is going to be looking to minimize costs in order to reach a certain level of output, or equivalently to maximize profits. So first we want to have a depiction of total costs for the firm. And those total costs are made up of labor costs, which are equal to the wage multiplied times the number of workers used, and the capital costs, which is the cost of machinery, which is equal to the return to capital R multiplied by the number of units of capital. You can rearrange this equation, solving for capital, where the slope of the line is the relative cost of labor, the wage-rental ratio, and that is the trade-off between purchasing labor or capital to produce the output. That wage-rental ratio will play an important part in many of the later aspects of what we do. The other part of the equation is the y-intercept, if you will, which is the total cost of outlays divided by the return to capital, that is to say the maximum amount of capital that can be purchased for that given level of total outlay by the firm. You can also depict this graphically in the following way, where the green line represents the equation of that line. The slope is the wage-rental ratio, the y-intercept is the total amount of capital that can be purchased, and the x-intercept is the total amount of labor that can be purchased for the same level of cost. Now suppose the cost of capital increased. Holding the wage fixed and the total amount of capital fixed, that will change this trade-off between labor and capital. In particular, the wage-rental ratio will fall because R has gone up while W remains the same. If the total outlay stays the same, the x-intercept remains the same, and the curve rotates downward. Now this will change the way capital and labor will be chosen. In the case of the no substitution between capital and labor, the rotation of this cost constraint for the firm will reduce the amount of output, but will not change the capital-labor ratio because there is no substitutability between capital and labor. That is to say, the final use of capital and labor will be along this same purple dotted line with this constant combination of capital. So this outcome reflects the inflexibility of this type of production technology. If the cost of capital goes up, the firm not only reduces the amount of capital, it also reduces the amount of labor that is used, because it must keep these two in the same proportion. Firms with this type of production technology are very vulnerable to changes in input costs. Now we want to move on to another extreme, that is to say, where capital and labor are perfect substitutes, so that the firm can use capital and labor indistinguishable between one another. So for example, if a level of production of 20 units required 8 units of labor, 8 units of capital, but alternatively the firm could use 16 units of capital, no units of labor, or alternatively 16 units of labor and no units of capital, and still get to that level of output of 20. This red line, this isoquant, reflects the isoquant when there is perfect substitutability between capital and labor. In this circumstance, the firms will be very sensitive to slight changes in the cost of labor or capital in choosing whether or not to use one or the other. Now, suppose that the wage was exactly equal to the cost of capital, so that the wage-rental ratio was 1, which happens to be exactly the slope of this isoquant. In that event, the firm would be indifferent between any combination of capital and labor that happened to be on the red line. Use 16 units of capital, no units of labor, 16 units of labor, no units of capital, or any combination in between. As long as it fell on the red line, the combination of capital and labor, the firm would be happy to purchase that amount of capital and labor. But this is a razor's edge. If the wage-rental ratio is anything different than 1-to-1 in this case, then the firm will choose to use only capital or labor. Say, for example, that we started out where the wage-rental ratio was slightly greater than 1. In that instance, the firm would face relatively higher costs of labor and would only use capital. That is to say, it could only reach the level of output associated with the red isoquant by choosing only 16 units of capital. Labor would not be chosen at all. The firm would completely specialize its production in the use of capital. Now, if the wage-rental ratio was slightly less than 1, slightly less than the slope of the isoquant, the firm would go in a completely opposite direction. In that case, labor is cheaper, and it will only choose labor and no units of capital. Again, a razor's edge. But these two examples, where capital and labor are either perfect substitutes or not substitutable at all, are the rarity. In general, there's imperfect substitution between capital and labor. That is to say, a firm has some ability to go back and forth between the use of the two, but not perfect substitutes. Capital and labor can be used in different proportions, and that proportion of the use of the two will depend on the relative costs of labor and capital that the firm faces. That is to say, the wage-rental ratio, the slope of this cost curve that we've been talking about before, will once again play a role. So here we have a capital and labor combination that yields a level of output, in this case equal to 15. Now suppose this level of 15 units could be accomplished with either 8 units of capital and 5 units of labor, or 7 units of capital and 8 units of labor. This means that different combinations of capital and labor, different proportions, can be used to produce this same level of output. These different combinations are also associated with different capital-labor ratios. 8 units of capital compared to 5 units of labor is a higher capital-labor ratio than for the other combination. So the question will be which combination to use, and that will depend on the labor cost compared to the capital cost, the wage-rental ratio. So once again, we'll bring in the cost side of the equation. The total cost curve depicted in capital labor space with the slope of the line equal to wage-rental ratio, so that the cost of capital and labor will determine the optimal amount of capital and labor given by K1 and L1. This is the maximum amount of output for this level of cost, and it is represented by where the isoquant is tangent to the cost line. That is to say, the slope of the cost line equals the slope of the isoquant. And this slope of the isoquant is known as the marginal rate of technical substitution. It's the change in capital compared to the change in labor. That's the slope of the isoquant. One can show that that marginal rate of technical substitution is equal to the ratio of the marginal productivity of labor compared to the marginal productivity of capital. That is, the trade-off between capital and labor on the production side equals the productivity of one input compared to the other input. So if we say that the equilibrium condition is where the slope of the isoquant, that is to say, marginal productivity of labor compared to the marginal productivity of capital equals the slope of the isocost line, then that means that MPL divided by MPK is equal to the wage-rental ratio in equilibrium. Let's examine this relationship more closely. First, let's start with the slope of the isoquant. First, let's consider a change in output along an isoquant. You can write this expression in the following way, where dy means the change in production. It's equal to 0 because we're holding output constant.